This is our first question, and this question reads, consider the following unbalanced equation below. So what we have in this equation is sodium chloride right here. Then we also have water. Sodium chloride is reacting with water, and this is also reacting with iodine. So in other words, we have three reactants, and we have two products. This is iodic acid and also sodium chloride. All right, so we have this equation, and this equation is not balanced at all. Now, according to what we're given here, we have 25.0 ml sample of 0.0833 molar sodium chloride reacted with 30.0 ml of an aqua solution of iodine. How many grams of iodine were contained in the iodine solution? All right, so this is the question that we have. We need to find or to calculate the mass of iodine. So now what is going to be our roadmap? How are we going to find the grams or the mass of iodine in this question? Let's look at the roadmap. So in order for us to solve this question, these are the steps that we're going to follow. Number one, we're supposed to balance the equation. Since the equation is not balanced, we're supposed to balance it. Then we're supposed to convert the given molarity to number of moles. So if we're given the mass, if we're given the mass for a reactant or a product, we're supposed to also do the same in this case. We're supposed to convert the given mass to number of moles. But in this case, what we have is molarity. So we're going to convert the given molarity to number of moles. Then we're going to use the mole ratio to get the number of moles for the chemical species of interest. So now, when you look at this equation here, we have the molarity for sodium chloride. Then we have not been given the molarity for iodine. So we're going to convert the given molarity to number of moles, the given molarity of sodium chloride to number of moles, so that we can use the mole ratio now to get the number of moles for the chemical species of interest. So our chemical species of interest in this case is iodine. Okay. After doing that, we're going to convert the moles. After calculating the number of moles, we're going to convert the moles to mass. So when you're given any question that is similar to this one, these are the steps that you follow. So let's now do step number one. Let's balance this equation. So for us to make sure that our equation is balanced, we have to make sure that the number of atoms on the reactant side are equal to the number of atoms on the product side. And when you're balancing an equation, start with any other element apart from hydrogen and oxygen. So balance oxygen last. All right, let's do that. Let's look at sodium. How many atoms of sodium do we have this side? So we have one atom of sodium this side. Then this side we have also one. So sodium seems to be balanced. All right, let's move to another element, chlorine. We have one element this side. Then also this on the product side we also have one atom of chlorine. So chlorine is also balanced in this case. Let's jump to hydrogen. Let's jump to hydrogen. Now, before we go to hydrogen, let's go to iodine. Iodine. How many atoms of iodine do we have this side? We have two atoms of iodine this side. Then what about on the product side? We have one. Iodine is not balanced. Iodine is not balanced. So what are we going to do to balance iodine? We have two atoms of iodine on the reactant side, then one iodine atom on the product side. So to balance this, well, we can put two in front of this. So if I decide to put two here, what do I have? Okay, I have two atoms of iodine on the product side. Then I also have two atoms of iodine on the reactant side. So to balance the equation, you just add coefficients in front of the products and the reactants. So the coefficient should not be a subscript. It also should not be a superscript. That's what we do. All right, let's move to another element. Iodine balanced. Let's move to hydrogen. Let's move to hydrogen. All right, so for hydrogen, we have two atoms here side. Then this side we have how many atoms on the product side? We also have two atoms on the product side. So hydrogen also is balanced. Now, by putting 2 here as a coefficient, we have created more problems now. We've created more problems. So let's remove these 2 and try another coefficient. Okay, so 2 here, 2 is not going to balance things. 2 is not going to balance the things that we want to be balanced. 2 is not going to balance the equation. All right, now let's try to put 6 here. What about if we put 6 here? Okay, so if we put 6 here, it's going to mean that we have 6 hydrogen atoms this side, 6 iodine atoms, then we're going to have 18 oxygen atoms on the product side. So let's make sure that we have the same number of atoms also on the reactant side. So, okay, we're going to put 3 here, okay? By putting these 3 here, what we mean is that we have 6 iodine atoms on the reactant side, which is equal the number of iodine atoms on the product side. So iodine is balanced. Now, what about hydrogen? We have 6 there. So what are we going to do to make sure that we also have 6 on the reactant side? Well, we just need to add 3 here as well. Then we have 3. We have 6 hydrogen atoms also on the reactant side. Hydrogen is also balanced. What about oxygen? To balance oxygen, we just need to put 5 here. Okay, we have, this is going to give us 15 atoms of oxygen plus 3 atoms of oxygen. That makes it to 18, which is the same number as the oxygen atoms on the product side. Now we have 5 sodium atoms on the reaction side. So to balance that here, we are also going to do the same here. So we put 5 there as well. So we have 5 sodium atoms on the product side, 5 atoms on the reactant side, 5 chlorine atoms here on the reactant side, 5 atoms of chlorine on the product side as well. So everything is balanced in this equation. So step number 1 done. We have a balanced equation. We're ready now to tackle step number 2. Let's look at the information that we have so far. So we know that we have 25.0 ml as the volume for sodium chlorate. Then for iodine, we have been given the volume also. So the volume here is 30. This is 30, okay? The volume is 30.0 milliliters ml. Then we've also been given the molarity for sodium chlorate, which is 0.0832 molar. All right, so what we're going to do is we're going to convert this given molarity to moles. That is what we're going to do. All right, let's do that. To convert the given molarity to number of moles, this is the formula that we're going to use. Number of moles equals concentration times volume. Very important formula. Okay, so now we have been given the molarity of sodium chlorate. Then we also have the volume for sodium chlorate. So we can easily convert this given molarity to number of moles. Now we need to be careful here. For volume here, the unit should be in liters. What we have been given is volume, which is in milliliters. So to convert milliliters to liters, we just need to divide by 1000. So that is basically what we're going to do here. So let's convert our given volume to liters. So we have 25 ml. So we just need to divide it by 1000. Okay, and this is going to give us 0.025 liters. Okay, so this is our volume. Let's now substitute everything into the given formula. So number of moles for sodium, this is sodium chlorate. Number of moles for sodium chlorate will be equal to the concentration, C, concentration, which is 0.0833. So the units it's moles per liter. Okay. Then we multiply this. We multiply this. Okay. Okay. Then what we're going to get is 0.00208 moles. We are ready now to tackle step number 3. And for us to perform this step, we need to have a balanced chemical equation. So we need to use this balanced chemical equation. So we have calculated the number of moles for sodium chlorate, and this is the number of moles for sodium chlorate. So now what we need to calculate is the number of moles for iodine. And for us to do this, we can simply use the mole ratio to get the number of moles for iodine. Let's do that. Let's calculate the number of moles of iodine using the mole ratio. So we want to get the number of moles for iodine. So this is going to be equal to, let's get the mole ratio. So we're going to start with what we're calculating for. We want to get the number of moles of iodine. So that coefficient in front of iodine is supposed to be on top. So we have 3 moles of iodine, 3 moles of iodine. Then down here, we're going to get the coefficient in front of sodium chlorate. What coefficient is in front of sodium chlorate? That is 5. So meaning we have 5 moles of sodium chlorate. Sodium chlorate. Okay. Then we're going to multiply this by the number of moles that we calculated in step number 2. So this is 0. Okay. This is 0.00208. Then okay, should be 208 moles of sodium chlorate. So that is sodium chlorate there. So you can see that this is going to cancel out with this. So what we're going to have is just the moles of iodine remaining. Now let's calculate. So what will be the number of moles for sodium? What will be the number of moles for iodine after calculating? Well, after calculating, you're supposed to get 0.0012495. Okay, 95 moles of iodine. This is the number of moles that we're getting for iodine. Okay, so step number 2 done. So now since we have the number of moles for iodine, we can convert the number of moles of iodine to mass. We're ready now to tackle step number 4. In order for us to convert the number of moles to mass, we're going to use this formula. Mass, which is M, is equal to number of moles multiplied by the molar mass. Okay, so MR is just the molar mass. All right, so let's do that. We know we have the number of moles. We have calculated the number of moles, and we know the atomic mass of iodine. So now we can substitute into the formula. The number of moles is 0.0012495 moles. Then for the molar mass, we have 2 iodine atoms. So the atomic mass of iodine is 126.9. You multiply that by 2, that will give you about 2. That will give you 253.8 grams per mole. That is the molar mass of iodine molecule. So now let's calculate. Let's do the multiplication. So what will be the mass? The mass is going to be 0.317 grams. So this is our answer. Okay.